Friends, welcome to my YouTube channel. Dhanesh here. Today we are going to discuss on feature engineering. This is the third video on feature engineering. In the last video, we discussed about the different techniques we can use for feature engineering. In this video, we will be discussing about the different techniques, or not different techniques. The first technique, imputation. For feature engineering, there are different steps to be followed. The first step is imputation. That step we are going to discuss in detail in this video. Let's start. So before getting into imputation, I am going to discuss about the different steps um, we need to follow in a machine learning problem. First is gathering data, cleaning data, feature engineering, defining the model, training, testing the model, and predicting the output. See, we are focusing on feature engineering. This is our area. Goal of feature engineering. Why we are doing feature engineering? Preparing the proper input data set, improving the performance of machine learning model. These two are the goals of feature engineering. What is not feature engineering? See, we need to understand data collection is not feature engineering, and data pre-processing is not feature engineering. Creating the tagged labels when labeling the data when labeling the data is not feature engineering. Scaling or normalization is not feature engineering. The principal component analysis (PCA) is not feature engineering. And the last step in machine learning, which we call the hyperparameter tuning and optimization, is not feature engineering. These are all not. So then, what's feature engineering? In feature engineering, we convert data into features. We convert data into features. That's what we do in feature engineering. So these are the list of techniques used in feature engineering. So we are going to discuss about the first technique, imputation, in detail in this video. The list of techniques we have to follow, list of steps we need to follow in feature engineering is imputation. Imputation means handling. How do we handle the missing data in the data set? Handling outliers, binding, log transform, on-hot encoding, grouping operations, feature split, scaling, extracting data. These are all the different steps we need to follow in feature engineering. Let's concentrate on imputation. How do we handle the missing data? In statistics, imputation is the process of replacing missing data with substituted values. When substituting for a data point, it's known as unit imputation. When substituting for a component of data point, it's known as item imputation. These are all the different methods we need to follow for imputation: deleting rows, replacing with mean, median, mode, assigning a unique category, predicting the missing values, using algorithms such as k nearest neighbors or random forest for finding out the missing values, deductive imputation, regressive imputation, stochastic regression imputation, imputation using most frequent or zero constant values, using deep learning. There are different techniques we can use to find out the missing values. I will be discussing around 6-7 important techniques that we usually follow in our projects. That's what I am going to discuss in this video. So let's start. See, if the first option is do nothing. See here the algorithm, if we are not handling the missing data, here the algorithm handle the missing data. Some algorithms can factor in the missing values and learn the best imputation values for missing data based on the training loss reduction. Example, XGBoost, extreme gradient boosting. XGBoost, we have a separate video on extreme gradient boosting under this ensembler ensemblers, ensembler learning. So there is a playlist, ensembler learning. See, under this you have the video for XGBoost. You can watch that. Some others have the option to just ignore them. There is light GBM. A light GBM is it's more advanced than extreme gradient boosting. It's from Microsoft. It's another algorithm for ensembler learning. You can watch. There is a separate playlist for ensembler learning. This light GBM is from Microsoft. There is another one is the cat GBM is there. That's all these algorithms are very important, and it's available and we are using in our projects as well. Some algorithms will throw an error complaining about the missing values. For example, scikit-learn linear regression, if there is missing values, it will throw error. In that case, you will need to handle the missing data and clean it before feeding it to the algorithm. So the second step, so the first one is we are not doing anything. The second step we can follow is the imputation using mean median mode. See this mean median mode, it's very important, and we have a separate video in under the playlist statistics. So you can watch that video to understand what is mean, what is median, and what is mode. Here we calculate the mean median of the non-missing values in a column, and then replacing the missing values within each column separately and independently from the others. It can only be used in numeric data. This is, you can understand that you can calculate the mean or median or mode if the data is numeric. If it is categorical data, we cannot use this approach. Pros easy, and the pros and cons of this, pros, it is easy and fast, work well with small numerical data set. We can't use with categorical data set. Cons, it doesn't factor the correlation between features. It only works on the column level. You can only use it in the column level. Will give poor results on encoded categoric features. You cannot give to categorical features. Not very accurate. Doesn't account for the uncertainty in the imputations. Then imputations using most frequent. It's a statistical strategy, and it works with a categorical feature. So this one will work with categorical features, strings or numerical representations by replacing missing data with the most frequent values within each column. Pros works well with categorical data, categorical features. Cons, it also doesn't factor the correlation between features. Correlation, you need to understand this is a statistical term. It gives the strength of the relationship between dependent and independent variable. We have very good separate videos for correlation. It is and r adjusted r square and how adjusted r square comes into picture. These are all important when you address regression problems. You can watch those videos in the playlist, statistics, and even in you have this video r and adjusted r square. So what is the importance of r square and adjusted r square? So all these things you can learn it when you address the regression problems. So as I discussed, correlation gives the strength of the relationship between dependent and independent variable. It can introduce bias in the data. That's another cons for when you use the frequent, using the most frequent. That's another cons. Zero or constant imputation, it replaces the missing values with either zero or any constant value you specify. That is another approach. Using the KNN. KNN means K nearest neighbors. K nearest neighbors is an algorithm. We have the video for K nearest neighbors in the playlist supervised machine learning. You can watch that. You can learn. It's an important algorithm to understand K nearest neighbors. This algorithm uses feature similarity to predict the values of any new data points. This means that the new point is assigned a value based on how closely it resembles the points on the training set. This can be very useful in making predictions about the missing values by finding the case closest neighbors to the observations with missing data and then imputing them based on the non-missing values in the neighborhood. Pros can be much more accurate than the mean, median, and mode approach. Cons: imputation, that is, this is computationally expensive because k nearest neighbors works by storing the whole training data set in the memory. This is, computationally it's expensive because this is another algorithm we are using to find out the missing values. Canon is quite sensitive to outliers in the data. Unlike SVM is support vector machines. It is, not sensitive to outliers. This Canon is quite sensitive to outliers. That's another thing you need to understand. When another approach, another algorithm you can use it in is the using the random forest. Another algorithm which can be used here is random forest. This model produces a robust result because it works well on non-linear and the categorical data. Random forest works well with categorical and non-linear data. It adapts to the data structure, taking into consideration of the high variance or the bias, producing better results on large data sets. This is another algorithm you can use to find out the missing value. Next is the multivariate imputation by chain indication, MICE. This type of imputation works by filling the missing data multiple times, not single times. All the methods we discussed, there we are filling only one. Here it is multiple times we are filling the missing values. Since the multiple imputations are much better than a single imputation, as it measures the uncertainty of the missing value in a better way. The chained equations approach is also very flexible and can handle different variables of different data types, continuous or binary, as well as complexities such as bounds or survey skip patterns. So this, if you want, you can explore more this method, this the maths behind this approach. You can explore more. I just give a simple introduction to this MIC. Imputation using deep learning. See, we this is another approach you can use by using the deep neural networks. You can watch too if you want to learn about the neural networks, the artificial neural networks, convoluted neural networks, or recurrent neural networks. All these things are there available in the playlist. You can learn. It's a very interesting topic. Deep. So here, this method works very well with the categorical and non-numerical features. It's a library that learns machine learning models using deep neural networks to impute missing values in a data frame. It also supports both CPU and GPU for training. So in a artificial neural network, there is input layer, there is hidden layer, there is output layer. The hidden layer, compute all these, calculations. So multiple hidden layers are there. It uses the backpropagation algorithm along with gradient descent for, reducing the cost function. It's a very interesting topic. You can learn this, backpropagation algorithm itself is very interesting. Gradient descent, all these things you can watch the videos in the playlist and learn this. So this artificial neural networks can be used to find out the missing values. The pros quite accurate. This deep learning, it's quite accurate compared to other methods. Neural networks are quite accurate. It has some functions that can handle categorical data. There is the feature encoder. It supports CPUs and GPUs. Cons: single column imputation, that is the cons, can be quite slow with large data sets. You have to specify the columns that contains information about the target column that will be imputed. So that's about the imputation using deep learning. So we discussed most important around 6 7 methods. We discussed how to handle the missing values in the data set. These are all coming under the feature engineering. So that's all about the first method. So in the next video we will be discussing about the next step. See, that's we have the different. See, this is how do you handle the outliers. So there are all these steps we'll be covering in the coming video. So then it will cover the entire feature engineering part. So that's all about this the missing values, how to handle the missing values. Thanks for watching. Please like, share and subscribe. Thanks a lot.